Section 19.2, static electricity. Molecules, again, have neutral charges when left alone. And electrons are free to move, easily separated by the nucleus. So, the electrons are zipping around the protons, and we can cause those electrons to move away from the protons. And when that happens, the charge of the atom changes. So molecules lose an electron, and then it becomes positively charged. So imagine a negative leaving that atom. So there's one less negative charge there. The proton that was associated with that electron is still there, so it's a positive charge. And molecules that gain an electron are more negative than they were positive, so they are negatively charged. Charge is neither created or destroyed, it's just transfer. So these charges can move. Electrons move around. They're very light, they're very quick, so they can bounce around very easily. Both are called ions. So you can have a negative ion or a positive ion. Negative ions have an extra electron. Positive ions have are missing an electron. And you use the friction method. By rubbing objects, you can transfer charge. So you rub your feet in the floor and rub two objects together, especially in dry air, you can create a charge. Conduction. This is direct contact, allows electrons to flow from one object to the next. So the wires in the house or in your phone conduct electricity. But a charge can build up on your body or on some object, and then if it gets close enough to a ground, the charge can discharge and conduct across like a spark. Material that allows free flow of electrons is called a conductor. Again, think of the wires or the printed wiring boards inside of your phone. Anything metal will be conductive. Gold, copper, aluminum are all great conductors. Not all metals are very good conductors, I misspoke earlier, but those three are very good. Materials that do not allow free flow of electrons are called insulators. Electrons are tightly bound and will not be free to move around. So this plastic comb is an insulator. Can't allow electrons to flow, but it can hold charges. It can actually hold a static charge. And what's happening in this picture, the static charge of the comb that you're brushing through your hair can actually pull the water over to the side. This slide's messed up, but insulators could be rubber and plastic and wood, cloth. A lot of materials are insulators. Now, induction is a rearrangement of close proximity. Think of like rods and paper. So you can charge up a plastic rod with, and if you had a lab, if you were in school, we'd do in these labs, we'd be charging up plastic rods by rubbing them and getting charges on one side or the other. And then we'll actually try to have you figure out through labs which is negative, which is positive. Moving electrons from one object to another is called static electricity. So the lightning you see in the sky, same thing. There's a charge in the clouds. It discharges either to another cloud or down to the ground. So you get electrons built up in the clouds. You have ice crystals going up and down, creating friction. They're hard objects. They're solids, and the charge builds up in the clouds, and they discharge. As you can see from this picture here, the ground, at the bottom of the clouds is where the negatives collect, and they'll discharge down to the ground. It says positive on this picture, but it's not that it's positive. This is a great amount of a negative charge here. It discharges down to the ground as a lightning bolt. Electron discharge, loss of static electricity. So once that happens, all the electrons leave, and things balance out again. And we'll have you do a little simulation that shows you the electrons moving around. Usually, electrons escape slowly through the air. So if you have a charge on your body from walking on a carpet, you have your socks on, you get a static charge. You touch a doorknob, it discharges quickly. But if you don't touch the doorknob, the charges will slowly dissipate. And in warm, moist weather, like in the summertime, that charge dissipates very quickly because the moisture is slightly conductive. And that's why static's more noticeable on dry days. Again, in the wintertime. Rapid discharge, shock, spark, crackle of noise. So when it happens, it's sudden. Otherwise, it's a slow dissipation, but no noticeable spark, no sound, no pain. Lightning caused by strong updrafts, again, rubbing up air particles. So as the warm air rises through the cold upper atmosphere, the snowflakes and ice pellets rub against each other, creating the charges. So the induction pushes negative charges away from the clouds, and lightning occurs. Earth easily accepts or gives off charges, or considered ground. It's got a large mass, a lot of conductive earth below your feet, and can easily dissipate the charge. It can hold a lot of charge. So these lightning, all these charges up in the sky, the negatives that may be accumulating, the Earth's so huge and so dense, it can hold those charges easily and totally dissipate them, spread them out. All right, things in contact with Earth are called grounded. So your house is grounded. If you have an antenna, I have an antenna on my roof, and you know the signal goes into the house, but the rest of it's tied to ground so that if lightning hits it, it goes right to ground, not to my TV. It hurts me. So you'll see this out by your electric box, by your house. You have a big copper stake, probably 4 feet long at least, goes down in the ground, and it's tied to your electrical box. So if lightning hits your house, it won't hurt you guys. This starts to take the easiest path, the shortest conductive path. So between these two devices, it's going straight. It won't go around and come back over this way. It has no reason to. It always wants to take the shortest path. Lightning rods bring the ground up to the top of a building. So you see houses that have little spikes on top of them, okay? And they attract lightning. So lightning won't go inside the house to go to ground. It'll go to there, which are then tied to the earth through a thick wire. No damage to anybody or electronics. Electroscope, I'll show you a little demo as you're looking at going forward with my assignments to show you how these work. You put like charges in here, and you have negatives on one side and negatives on another, and those like charges repel, and you'll see these flakes or these tabs repel.